Here we go, friends. We're in Chapter 3, Section 3. We're going to be solving equations by using multiplication or division. No real vocabulary today except for this really important key concept where we'll talk about two key concepts today. One of them is the multiplication property of equality. And this little property is going to be really important because what it does is it gives us the power to say that if I've got a number equaling itself, two things on either side of an equation that's equal to one another, if I were to multiply both sides by a number, the equality of the original equation would be maintained. So notice that if I multiply both sides of an equation by -3, I'm going to get the same value on either side. If I multiply both sides of an equation by a fraction, I'm going to get the same value on either side. So the rule says in symbols, if A is equal to B, then A times some number C is going to be equal to B times some number C. Therefore, I can multiply C on both sides of the equation and maintain equality. You've heard it before. What you do to one side, you've got to do to the other to maintain equality. So here we go. We've got this situation in example 1. We want to use multiplication by a positive number. So I've got T over 30 is equal to 7 over 10. What can I multiply both sides by in order to get T free? And the easy answer is that, remember the last video I would say, oh, who's bothering T? And in this case, 30 is bothering T. What's 30 doing to T? It's dividing. To undo division, we multiply. So I'm going to multiply both sides by 30. All right? And I know this gets into multiplying by fractions, but we're getting good at this. To multiply fractions, we multiply top times top, bottom times bottom, or numerator times numerator, denominator times denominator. So it would be totally legit to write 30t over 30 is equal to 7 times 30, 210 over 10. However, most of the time when we multiply by 30 like we're doing here, we're doing it to get rid of the 30 in the denominator. So I wouldn't actually go from here to here. I'd actually just cancel it out and say, oh, I've got T. Now, if you went from here to here, you'd see that 30 goes into 30 and you still get T. So it's not a big deal. Over here, instead of multiplying 7 times 30, getting that 210, and then 10 times 1 and getting 10 in the denominator, what I would do is do something called cross cancel. So I know that 10 goes into itself 1 time and 10 can go into 30 3 times. So then when I'm done, instead of getting 210 over 10, which I'd have to divide, not too hard to do, I would end up getting 7 times 3 is 21 divided by 1. 1 times 1 is 1. And then I get that T is equal to 21. All right, so this is the process that I would use. Let's go back and just talk about what we did. We recognized that we wanted to get T alone. We asked ourselves, who's bothering T? That was 30. How is 30 bothering T? By division. How do we undo division? By multiplication. So I multiply both sides of the equation by 30. Canceling out my 30s over here, I'm left with T. Reducing 10 and 30 to be 1 and 3, I'm left with 21. So T is equal to 21. We were asked to check this. When we check, it makes good sense to rewrite the problem as it originally was. And then we're going to just simply substitute in our answer to see what we get. And so when I do that, T is replaced by 21. What would I do if I were doing an ordinary problem? I would reduce this. What number goes into 21 and 30? 3. So 21 divided by 3 is 7, and 30 divided by 3 is 10. And woohoo, I see that I've got the same answer on both sides, which tells me that my answer was correct. Let's take a look at this guy. We're going to solve using multiplication by a fraction. So here we have 2 and 1/4 g is equal to 1 and 1/2. So let's write this uncomfortable problem down. 2 and 1/4 g, so that's 2 and 1/4 times g is equal to 1 and 1/2. Now facts, anytime you are dealing with multiplying fractions and you have a mixed number, you ought to change that mixed number into an improper fraction, which means bigger at the top, smaller at the bottom. No, nobody likes my saying. That's fine. So it means that the numerator is going to be larger than your denominator. How do I turn this mixed number into an improper fraction? I'm going to show you. So 2 times 4 gives me 8, plus 1 more gives me 9. So this is actually 9/4. So 9/4 G is equal to, and since we're in the business of turning mixed numbers into fractions, improper fractions, let's do it over here. 1 times 2 is 2, plus 1 more is 3. So what I end up having is 9/4 G is equal to 3/2. Notice that these are equivalent fractions. It means the same thing. Haven't changed any values. I'm just changing the look of the function. The look of the equation. So 9/4G, I got to get rid of this 9/4. Fact, to get rid of a fraction like this, instead of trying to do like division or multiplication, well, division, like trying to divide it away, I'm going to suggest we multiply it by the reciprocal. Do you remember we talked about multiplying by the reciprocal cancels out that fraction? Let me go over here and do a quick. Do you remember A over B times B over A ends up with cross cancel 1 over 1, which is 1, right? We could have written AB over BA and then did some canceling out, but we still get 1. The fact is, when you multiply a fraction by its reciprocal, it cancels it down to 1. And you'll see over here, notice, I'm going to multiply this fraction by the reciprocal 4/9. But wait a minute, what I do to one side, I can't forget this, I've got to do to the other. So I'm going to multiply this guy by 4/9 as well. Again, I'm trying to maintain equality. I'm doing this over here to get rid of the coefficient, or to make the coefficient of G 1. So these guys cancel, and woohoo, I get 1G left on the left side. On the right side, I've got to deal with this guy. But remember, we can multiply straight across, get 3 times 4 is 12, 2 times 9 is 18, and then we can reduce it. But I'm going to reduce early by cross canceling. 2 goes into itself 1 time, and 2 goes into 4 twice. 3 goes into itself 1 time, and 3 goes into 9 3 times. So now when I multiply 2 times 1, I get 2, and 1 times 3, I get 3, and my answer is 2/3. Kind of cool, huh? I can check this problem by plugging this value back in to the original equation. So I will be multiplying 2/3 times 2 1/4. I'll write that neater in a minute. So 2 1/4, I'm going to change that to an improper fraction. That improper fraction would be 9/4. So now what I'm dealing with is 9/4 times 2/3 is equal to hopefully 3/2. So if I can get this to equal 3/2, I'm good to go. How would I do it? Cross cancel again, right? And we can see that when we do that, we get 3/2 is equal to 3/2. So we can feel confident about our answer being correct. So G is equal to 2/3. Here we're going to solve using multiplication by a negative number. When I look at this problem, 42 is equal to negative 6m, I actually don't think of multiplying, and I'm not going to encourage you to multiply. We could multiply by a fraction, but I'm going to talk about something else. We're going to talk about the equality property of division, and I think they're probably going to have it down here. Here it is. We're going to kind of bounce around a little bit. The division property of equality basically says this: if you have two numbers, A and B, which are equivalent, and as long as C is not equal to 0, that's important because if you divide by 0, bad things happen, mathematicians get upset, all this stuff. Basically, it's totally illegal to divide by 0. So oftentimes when you have a division problem with a variable, somebody's going to say C is not equal to 0, or that variable is not equal to 0. So this is kind of like a disclaimer. Now, let's get back to the division property of equality. If I have A equals B, two numbers that are equal to each other, if I divide both of those numbers by the same number, equality will be maintained. And that's what's being displayed here. So what I'm going to do is use that fact to solve a problem over here. So remember when I asked myself, who's bothering M? I want to get to know M, and who's bothering M? -6 is bothering M. How is -6 bothering M? By multiplication. What is the opposite of multiplication? Division. So I'm going to divide that -6 away. But what I do to one side, my friend, I've got to do to the other. And so now the -6 goes away. I'm happily left with M all by itself. And now I've got to do some work here. 42 divided by -6 is going to be a -7. Remember, 42 divided by 6 is 7. And when I divide a positive by a negative, two different signs, my answer is going to be negative. Let's go. So we've got to write and solve an equation using multiplication. So refer to the information about space travel to the left. The weight of anything on the moon is about 1/6 its weight on Earth. What was the weight of Neil Armstrong's suit and life support packs on Earth? So let's go to our bit of information here. We see on July 20th, 1969, Neil Armstrong stepped on the surface of the moon. His suit and life support weighed about 33 pounds on the moon. So on the moon, it's 33 pounds. Let's write that information down. On the moon. And we're given some information here. It says the weight of anything on the moon is about 1/6 its weight on Earth. So the weight of things on the moon is equal to 1/6 the Earth weight. So this is my little mental device to help me figure out where I'm going to put what. So we want to know how much did this stuff weigh on Earth. So E is going to be our variable if we know how much it weighed on the moon. So I'm going to replace the 33. So it was 33 pounds on the moon, which is 1/6 of its Earth weight. And so how do I solve this? Well, I've got a fractional coefficient of E. Who's bothering E? 1/6 is bothering E. How do I get rid of this fraction? Multiply by its reciprocal. So I'm going to multiply by 6/1. What I do to one side, I've got to do to the other. That cancels out to leave me with simply E. Now I'm going to multiply 6 times 33 and get 8. Carry my 1. 6 times 18, 19, 198 pounds. So this outfit, his life support suit and his backpack would weigh approximately 198 pounds on Earth. And so we discussed the division property of equality, and we're going to do, I think, 2 more problems before we get out of here. So this guy requires that I isolate S. Again, I'm going to solve. Isolate S. Who's bothering S? 13 is. How is 13 bothering S? By multiplication. So I'm going to divide both sides by 13 because I undo multiplication by division. When I do that, I'm left with S on the left side, and on the right side I've got 195 divided by 13. Well, 13 goes into 19 one time with a remainder of 6, and 13 goes into 65 5 times. So S is equal to 15. How do I check it? Go back to the original problem. Plug in your answer in for the variable. So 13 times 15 is 195. And I'm going to multiply 13 times 15. And when I do that, I actually get 195. I really did do it mentally. I know you think I'm just saying it's right, but I really did do it. Trust me, trust me. And if you want to check with a calculator, you can, or check with long multiplication. But it's right. I promise it is. Let's look at this final example for this section. Example 6 says solve using division by a negative number. And so here, same idea. X, who's bothering you? -3. How do we get rid of -3? We divide her away. What we do to one side, we do to the other. I'm left with X is equal to 12 divided by -3, which we know 12 divided by 3 is 4. Positive divided by negative is negative. Did they tell me to check it? I don't want to, but I'll do it anyway. I check by taking the original problem, plugging my answer in for the variable, and hoping everything works out beautifully. -3 times -4 is a positive 12. 12 is equal to 12. Make it a 12. Woohoo! I'm feeling good. Guys, I know we kind of went through a little bit of redundancy here. I hope that the fraction parts, the fraction examples do make sense. We're going to be in the next sections bringing a lot of these concepts together. So please let me know if there's anything I can do to help make sure that section 2 and section 3 are clear before we move on to section 4. All right, guys, take good care. I look forward to seeing you and talking to you soon. Bye-bye.